Thank you. My name is Sofonyas, and I will present this research on behalf of the co-authors. As we know from the previous literatures, we know that soil conditions are very important for carbon dioxide removal. And in our HESP trial, the 5-year-long trial, we found no CDR in acidic soil. So can we modify the soil pH and carbon dioxide concentration of soil to achieve higher CDR? That's our research question, and we try to investigate that. This is my title. And the aim of this project is to determine the effect of soil management aimed at changing the pH and soil carbon dioxide concentration on CDR. And we have two factors here, soil management and the basalt rate. So we replicate those treatments 6 times, and this is the layout. And we use randomizer complete block design as a design. So for the soil management treatments, we applied mulch, lime, potassium, and phosphorus at planting. And we used the nitrogen, potassium, and phosphorus following the Australian sugarcane nutrition manual. And we applied nitrogen in split application. So we also collected the soil water. The water is the leachate and runoff. And we collected runoff from using this splitted system based on Pinson. And we constructed the runoff pits in 0 and 50 ton per hectare of basalt with management. And this is the design, the device we installed at 1 meter depth to collect leachate. And this is a drainage flux meter. And this is a sample plot. And the green one is the sugarcane. And the numbers are the spots where we collected post-harvest soil to come up with one composite soil sample. And here is this is a spot where we installed the soil atmosphere to collect the concentration of carbon dioxide. And we installed this soil atmosphere sampler in 12 plots, so 6 in control and 6 with amendment. And this is where we installed the drainage flux meter. So we collected the water soil samples following those procedures, and we analyzed it accordingly. So this is the pre-planting soil properties. So we analyzed up to 5 depths up to 1 meter, and the pH is slightly acidic and decreased with, there is some inconsistencies, but it decreased with depth. And the dominant non-acidic cation is calcium. And the cation exchange capacity and total carbon was low, and it decreased with depth. And to start with the result, this is the water balance for this wet season, starting from the 19th of December to 5th of May. We received this amount of rainfall. Out of this, 11% was runoff and 32% was evapotranspiration, and deep drainage was 57%. And this is, as I mentioned earlier, we have 12 plots for carbon dioxide measurement. So here, this covers for the whole wet season. We started sampling the wet season early January up to May. And as you can see here, the control is with no amendment, but with basalt application, 50 ton. And the application of lime, mulch, and fertilizer significantly increased the soil carbon dioxide concentration. As I have mentioned at the start of this presentation, here we try to modify, we achieved the modification to modify the carbon dioxide concentration. This is the soil properties after 1 year for the first step, that's 0 to 10 centimeter. So application of basalt significantly influenced total carbon, exchangeable sodium, extractable phosphorus, and extractable silicon. And the soil management significantly affected all the variables except exchangeable aluminum and extractable silicon. So I will present some of the variables in detail. But here application of basalt or their interaction with soil management treatments had no effect on soils deeper than 10 centimeter. The pH was significantly affected by soil management, which is the lime and lime plus mulch plus fertilizer. Here, as I have mentioned in the table, the pre-planting soil pH was 5.97, and we achieved to increase the soil pH like 6.5 to 7, but there was no pH increment by the application of basalt for this depth, and this is the first year result. And the soil exchangeable sodium increased with the application of management, and interaction effect, as you can see here. And this is a clear evidence of weathering after application of 50 ton of basalt at 0 to 10 centimeter depth. Extractable silicon increased with basalt application. There was no management and their interaction effect here. As you can see here, the extractable silicon increased with 50 ton application of basalt. Extractable phosphorus also increased with basalt and application of lime plus mulch plus fertilizer and lime mulch plus fertilizer. But there was no interaction effect here. Cation exchange capacity increased with soil management, but no basalt effect here or their interaction. This is the leachate. We collected leachate from 15 leachate events. So we did cumulative alkalinity export. As we know, this alkalinity export is the measure of CDR, and we reported in kilomole per hectare, and 1 kilomole per hectare is equivalent to 44 kilogram of carbon dioxide per hectare, and there was no basalt and management effect on alkalinity export. But here, there is statistical interaction effect due to the application of lime with zero basalt application. We also did harvest the first year sugarcane in 2025, and this is the total yield and stock weight significantly influenced by the application of lime plus mulch plus fertilizer and mulch plus fertilizer. Here we had no significant effect or no agronomic benefit out of basalt. As a conclusion, significant weathering of basalt within 1 year, as I have mentioned there, the sodium one, and soil properties and sugarcane were affected by soil management, but not by basalt or their interaction. The CDR was not significantly affected by basalt, soil management, or their interaction. And as I have mentioned at the start of this presentation, we modify the pH and concentration of carbon dioxide of the soil. We didn't manage to achieve CDR for this first year. Perhaps this this result is only the first year result, so we'll continue experimenting and try to investigate the process behind. Thank you.